Hey, hey. Okay, so next up is quotient rule. Quotient. I hope that's familiar to your ears. Quotient. Product rule. Product means multiply. The opposite of product is quotient, which means we're dividing today, division. So I want you to make a little vocabulary note to yourself that quotient means division or divide. Okay. Okay, so we are dividing terms today. A lot of us still think of this little division symbol when we think of division, which I totally understand. But I hope you know that in my class, we don't really see that symbol a lot. How do we show division? We show the fraction bar. And that's what you're going to be seeing today. But every once in a while, you might see something like this. X to the sixth divided by x to the second. Okay. You might see like that maybe on Delta Math, but I don't think so. Delta Math does fraction bar as well. But just know that this means it's the same thing as x to the sixth over x to the second. A fraction bar literally just means division, okay? So 90% of the time you're going to see it like this, x to the sixth over x to the second power. Now let's go ahead and expand this out, okay? We're looking for the rule on what to do when we divide things with the same base, but let's kind of see if you can figure out the rule yourself. So let's expand out x to the sixth. That would be 6 x's being multiplied. X times x times x times x times x times x. 1, 2, 3, 4, 5, 6. On the bottom, you have x squared, which is just 2 x's being multiplied. X times x. Okay. Now, when dividing, I hope we remember that when you divide any number divided by itself is 1. But that also applies to variables. So you don't have to write this down unless it's helpful to you. You totally can, okay? But like 4 divided by itself is 1. 4 divided by 4 is 1. Negative 100 divided by itself is 1. X divided by x is 1. Anything divided by itself is 1. Potato divided by potato is 1. Yes? Okay. So what you're going to kind of look for is you're going to group up and go, okay, if I just look at this x dividing by this x divided by x is 1. So it's almost like they cancel each other out. And then this x divided by this x divided by x is 1. So it cancels those out. Okay, because 1 times anything is just itself. So now it's like you have 4 x's being multiplied, which would be x to the 4th. And then nothing's left on the bottom except technically there's a secret 1. Okay, but anything divided by 1 is just itself. So final answer, x to the 4th power. Okay, so you're looking for the rule, you're looking for the relationship between what we started with and what we ended up with. X to the 6th over x squared somehow was x to the 4th. I showed you why, the nitty gritty steps on why, but I'm hoping you see a relationship between between 6 and 2 and how we got 4. Okay, so just to look back, the opposite of division is multiplication, which is your product rule. Product rule says that when you're multiplying things with powers and they have the same base, you just add the exponents. I guess I forgot to write the base and add the exponents. Go back in your notes and hopefully you wrote that down. Sorry, add the exponents. Anyways, so when it's multiplying, you add the exponents. When it's dividing, you subtract. 6 minus 2 is 4. Okay, so that is the rule. So let's write it down. When dividing and the bases are the same, when dividing and the bases are the same, keep the base and subtract the exponents. When dividing and the bases are the same, keep the base and subtract the exponents. Okay, so x to the 6th over x squared, you just keep the x and then you do top minus bottom for your powers. 6 minus 2 is 4. So x to the 4th would be your final answer. Okay, let's do some practice. So we have w cubed divided by w squared. This one I want to expand out, just do one more, expand it out. Okay, so visually how we see this is 3 w's being multiplied on top, w times w times w, divided by 2 w's on the bottom being multiplied, w times w. And then you kind of go through and think to yourself, well, w divided by w is just 1, w divided by w is just 1. So I'm left with w over 1, which is just w, okay? We could also use the quotient rule, which is what you're going to use on the rest of this page anyway. Quotient rule says when dividing and the bases are the same, w divided by w, you just subtract the exponents, top minus bottom. And in fact, you might want to add that right here, top minus bottom. So the power in the numerator subtracted by power in the denominator. Okay, 3 minus 2 is 1. If you wanted to put the 1 there, you could, it's just not necessary. Number 2, we have x to the 50th power divided by x to the 3rd power. This is one where you most definitely wouldn't want to do 50 x's and then 3 x's and cancel out. You can kind of visualize it though. You'd be able to cancel out 3 things and then you'd have 47 x's on the top left. Okay, but really this is equivalent to just keeping the bases and taking the top power of 50 and subtract the bottom power of 3. So this would be x to the 47th power. 50 minus 3 is 47. Number 3, okay. Number 3, we have b squared divided by b to the 5th. B squared divided by b to the 5th. Now before you just go, oh, b cubed, b to the 3rd. Careful. We said you got to subtract the top power by the bottom power. So this would be b to the, and then we take the top power, subtract the bottom power. 2 minus 5 is negative 3. So this would be 2 to the negative 3rd power. Why did I get 2? I don't know where the 2 is from. B, sorry. B to the negative 3rd power. B to the negative 3rd power, I can't leave that as my answer. Okay, we've talked about this. We can't leave negative exponents in our answer. So you do have to convert this or change this so that your power does become positive 3. I'm hoping you remember how. B to the negative 3rd is the same thing as 1 over what? 1 over b cubed, b to the 3rd. 1 over b to the 3rd. That would be your final answer. Okay, so you got to be super careful with how you subtract and if there's negatives. Number 4. Gonna have a big old fraction bar, okay? We have 20 times x to the 5th on top over 5 times x squared on the bottom. Okay, I don't typically break this apart, but because this is the first one where we've seen kind of a lot of stuff divided by a lot of stuff, I think it's good to kind of break it apart. So the coefficients, you're dividing the coefficients. So this is the same as 20 divided by 5. So we can kind of break that up into its own little thing. And then we're timesing it by x to the 5th over x squared. So you can break it apart if that helps you think of it better. And then you would simplify this down. Well, 20 divided by 5 is 4. And then we're timesing it by whatever this is. X to the 5th divided by x squared. They have the same base, so I can use the quotient rule. So I keep the x, and then I do 5 minus 2, positive 3. So 4 times x cubed. I can write it like this though, final answer, 4 times x cubed. All right, so these in-between steps, you don't have to do them every time, but really you would just know in your head, 20 divided by 5 is 4, x to the 5th over x squared, 5 minus 2 is 3, so it'd be x cubed. That's what I do, okay? Here's number 5. This has a lot of stuff in the top and a lot of stuff in the bottom, so here we go. Numerator is 3 times x to the 10th times y squared times z to the 7th. In the bottom, you have 5 times x times y to the 5th times z squared. Whew. Double check that you wrote that down correctly. Okay. You can break this apart. I think it might be a good idea on this one. So let's just do our regular numbers. 3 divided by 5. If you were to do that in a calculator, you'd get a decimal. We don't want that. Just leave it as 3/5. Okay, it's simplified. And then I'm going to simplify my x terms. X to the 10th divided by x. Keep in mind there's a little 1 right there, right? So 10 minus 1 makes it x to the 9th. Okay, now let's look at our y terms. Y squared divided by y to the 5th. 2 minus 5 is not 3, it's -3. Okay, and then z terms, let's do 7 minus 2, +5. So we get this. Now, in our final answer, I know that this is going to result in a large fraction, a big quotient again, just because 3/5 did not simplify down for us. So I'm going to put the 3 on top and the 5 on the bottom, and then we'll just fill in where the pieces go. X to the 9th, do you think we should leave it on top, or do we have to change it to the denominator? X to the 9th, that's a +9, so we're happy with it. We don't need to change it anyway. This is where you have to think about how to deal with your negative exponent. Y to the -3rd, technically it's kind of on top of your fraction. So the easiest way to make that y to the +3rd is to just bring it down to the denominator. So it can be y to the +3rd. So that fixes our issue of a negative exponent. Z to the 5th already has a positive power, so we leave it on top. So this would be your final answer. Okay. Okay. Let's do just one more. Okay. Try this out. On top, you have -18, a to the 8th, b cubed. Okay. On the bottom, we have 2 times a to the -2nd times b to the 10th. Pause the video, see if you can think through that on your own, okay? Okay, for me, I see a couple things. So I'm gonna kind of break this apart. Negative 18 divided by 2 is negative 9. Yes? Okay. And then I'm going to deal with my A's. Right here, I hope you were super careful. We have to do 8 minus negative 2, not 8 minus 2. So if you got a to the 6th power, that'd be wrong. This has to be 8 subtract negative 2. 8 minus negative 2 ends up being 8 plus 2. So the power right there is going to be a 10. Okay. And then right here, I'm going to finish it up. B to the 3 minus 10 is negative 7. Okay. So in my final answer, negative 9 has a positive 1 for a power. So we're going to leave it on top. Right here, 8 plus, this ends up being 8 plus 2. So that's a to the 10th power. Positive 10, we like it. We don't have to change it. This guy, we cannot leave it in a numerator. We have to make it become b to the 7th power. So the easiest way to do that is just put it in the denominator, b to the 7th. So this would be your final answer. Negative 9 times a to the 10th divided by b to the 7th. It takes practice, okay? But I'm hoping that like questions 1 through 3 were completely fine, okay? If you feel good about 1, 2, and 3, I'm okay with that. This stuff we can work on in Zoom. All right, thanks guys. Thanks for watching. Appreciate you.